Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic at hand is kind of a twofer. We're going to get a twofer tonight. So LIN Bus and new module initialization. They're very closely tied together. But we've had questions over time about, what is LIN Bus? How does it work? How is it different than, say, CAN bus or anything else we might use on a car? So we'll talk about that first. So starting off with LIN Bus. LIN Bus is a network, much like any other network on a vehicle, and works on a voltage differential. So as long as the on and off, the ones and zeros of the electrical signal are going across and they fit above a certain threshold, in this case, LIN operates on a 12-volt voltage differential. So if we see here, the top part is 13.35 volts. It's running, the alternator's on. This is actually an alternator sensor. And then cursor 2 is at 0.91, so not quite all the way to 0. So it doesn't go 12 to 0. It's just a 12-volt range somewhere in between. So we see the delta, or difference between those two, is 12.44. So that means it's operating above its threshold that it needs to set in order for it to be considered a valid piece of data. And it looks good. This is a known working vehicle, and just to kind of capture the pattern of what would I see if I were to hook up on a scope and look at a LIN bus. So this is like 5 milliseconds. So we're seeing a fair amount of data in that 5 milliseconds. But these are the bits and bytes, the ones and zeros that go back and forth. So LIN stands for Local Interconnect Network. It was specially developed to achieve cost-effective communication for intelligent sensors and actuators in motor vehicles. So to cut down on wiring complexity, I guess, they came up with this LIN bus. So the Local Interconnect Network bus consists of a single wire with a transmission rate of up to 20 kilobits per second, and it uses a 12-volt differential like we just said. It is a master and a slave type configuration, so a switch and a motor, that sort of thing. You can have multiple slave modules running off of one master. They're also starting to change the nomenclature a little bit, so you might also hear it referred to as commander and responder, right? So the thing sending the command and the thing responding to the command. And it's going to be set up something like this. You're going to have your master controller, whatever that happens to be, and then your responding controllers down here. That can be up to 16 total per on a network. Master, and then all your other controllers down there. So for example, things where we might see this would be, say, like roof, like sunroof controls, steering wheel. Definitely, a lot of vehicles, any of the steering wheel buttons run over LIN. Seat, we're going to look at one here in a little bit on a seat for seat position motors, occupant sensors. Engine sensors and small motors as well. Grill shutters, small motors and climate control, like your blend doors and things like that. Mirrors, window lift, seat control switches, door locks, so like your master switch there, that probably runs off a LIN as well. So let's look at a seat. So this is off a Cadillac. And let's see, driver seat adjuster switch. So ground is supplied at all times to the seat adjuster switch. Battery positive voltage is also supplied at all times to the seat adjuster switch through a 10 amp fuse located in the fuse block. When the seat adjuster switches are pressed, the appropriate signal message is sent to the seat memory control module via a LIN message. The seat memory control module then commands the appropriate seat motor to move in response to the switch signal message. This is for the passenger side, works the same way. And then the lumbar support, if it has that, seat switch communicates all customer requests for a seat movement or adjustment via the LIN serial data bus to the seat adjuster memory module. Seat switch making consists of the following controls: a seat adjuster, two-way lumbar, forward, rearward, two-way bolsters, can be activated up or down. Manipulating the seat cushion and seat back control bar results in the seat memory control module responding in the same way as if the resultant requests were made by discrete signals instead of the LIN messaging the switch employs. So it's going to look something a little bit like this. So we're going to see we got the switch is going to send a signal, ones and zeros, bits and bytes, over to the control module. And then from the control module, it will then decide, well, this motor needs to move up or down. This motor needs to move, front or back or whatever it happens to be. So the switch sends the command to the module. The module then processes the command and sends it out to whatever motor needs it. I guess it makes it less wiring involved total. We're not dealing with relays and so much. I mean, I guess to a point, sometimes we are. But fewer relays, fewer point-to-point wires and things like that cuts down on the complexity of the vehicle on the hardware side of things, I guess. Now, the other side where it might get a little complicated is on the back end with software and stuff like that, initializations and things like that. And then there's just a reminder of what a typical LIN signal looks like. So, 0 and 1 goes down. There's a lot of separate zeros and ones, one after each other, and there's a whole bunch of ones there and a whole bunch of ones there. So computers only know binary, right? They only know on or off, 1 or 0. So this is how it kind of processes it, and that's a whole packet. That's actually not even an entire packet of data, but this is how the data is presented, right? So it should look like a square wave. All right, that leads me to new module initialization, because oftentimes on a LIN, you need to reinitialize the modules when you replace them, amongst many other things on a vehicle, as we may know. So there's different terms that get tossed around out there all the time. And some of them, more than others, can kind of get conflated with each other. And, the OEMs are just as bad as the aftermarket with this and saying, confusing the terms, which confuses the technician who wants to work on the vehicle and just needs to know what they want to do. So if I need to initialize or put in a new part or something like that on a vehicle, oftentimes it needs some sort of a function afterwards in order for it to work. Be it a reset, or relearn, a coding operation, a programming operation, or flashing or reflashing operation. It really kind of falls into these 5 buckets. So let's talk through each one of these individually and kind of just define what these terms are so we can kind of understand and talk the same language. So first one's resets. That is the simplest one. What this does is it resets a parameter back to factory specifications. Whatever it was when it was brandy new, it's going to set that back. So for example, oxygen sensor heater on GM vehicles, other vehicles too, but on GM vehicles for sure, the oxygen sensor changes the amount of current flowing to the heater, or the controller changes how much goes to the heater in order to heat it up at a certain amount of time. As it ages, that amount increases. So we need to bring that back down to factory spec. We put a new one in there. Same thing with transmission shift adaptives. Most transmissions nowadays will learn how you drive. If you drive a little more sporty, it'll shift a little more sporty. If you drive a little more conservatively, it'll shift more conservatively. So if I do any work to that, replace a valve body, rebuild clutch packs, whatever I happen to do, I need to reset those adaptives, because they also can adapt for wear as well. So if I have no wear and it's adapted to the wear, then things might be off. I might get harsh shifts and all sorts of unintended consequences. So we would need to reset the adaptive. Super simple. In this case, we're on a Zeus and it has service resets and relearns. So on those are broken down by job, and it'll pull in any resets or relearns you need. So in this case, replace a relearn oxygen sensor will go in there. Gives you any bulletins related, and also pulls back any functional resets, calibration, bidirectional controls. In this case, there's only one, could be multiple, depending on what we have, depending on, it could be in multiple modules where I need to reset it. And we could go in there and do that, and it would pull that information up for us. So on the next screen, select reset. It's a simple checkbox on the top of the screen. It's a touch screen. You tap reset, it's done. That easy. Most resets are that way. I'm just resetting it back, wiping out the whatever it learned and then just resetting it back to factory stock. Next one's relearn, so it's a little more complex. Relearns are used to teach the ECM parameters of a replacement part. For example, change the throttle body, the computer needs to know where's full throttle, where's full close, right? Because every single component is going to be a little bit different, even in the tiniest manner, in the tiniest way. It still could be different from part to part. This building tolerances, construction tolerances, whatever, assembly tolerances. So if I replace a throttle body with a different throttle body, it may have different operating parameters than the one that I replaced. Same thing with valve body learn. If I replace some solenoids, the solenoids might have different characteristics and I need to relearn those. And TPMS. TPMS in and of itself, when I rotate the tires and I need to tell the computer, well, it's not on the left front anymore, it's on the right rear, then that learns or it teaches the ECM where that tire is. Right? So once again, we'll go into service resets and relearns. In this case, we're on a Murano, so that means we probably replaced the throttle body, right? So we have a perform idle learn procedure there. And then we have the idle air volume learn. Now this one seems to be a relearn that some people struggle with. A fair number of people struggle with it. We get calls on this all the time. Hey, it's not working. It's not doing it right. Idle air volume learning is a function of learning idle air volume that keeps the engine idle speed within a specific range. Must be performed under any of the following conditions. So each time the IAC valve, throttle body, or ECM is replaced, idle speed or ignition timing is out of specifications. Any of those occurrences. So we got to put it in the right mode first. Accelerator pedal release position learning. Make sure the accelerator pedal is fully released. Switch on for 2 seconds, off for 10, on for 2, off for 10, hit continue. Throttle valve close position learning. Make sure the accelerator pedal is fully released, on for 2 seconds, off for 10 seconds, and then make sure that the throttle valve makes a sound when it's with the off position. Because here's the thing with relearns. Relearns oftentimes have many parameters that need to be met, and if they go outside of those parameters at any time, it will cancel. And sometimes it'll tell you why. Sometimes it'll tell you the parameters you need to hit. Sometimes it won't. Sometimes it'll just say, oh, conditions not met. And anytime it says conditions not met, like on a GM vehicle, it's the car telling you that, not the tool. So the car says, oh, the temperature is not right. So example, before performing this, make sure all the following conditions are satisfied. Learning will be canceled if any of the following conditions are missed for even a moment. So battery voltage more than 12.9. For some reason, it drops to 12.8. Done. Start over. Coolant temperature, 70 to 100 Celsius, gets to 101. Forget it. Start over. Gear selector and parker neutral. All electrical loads off. Vehicles equipped with daytime running lights, set the parking brake. Steering wheel, straight ahead position, centered. Don't touch the wheel. Transmission warmed up. Drive vehicle for 10 minutes. Key on engine running. Idle not excessively high. Non-idle related codes are cleared or repaired. So if all that is set, select continue with the key on engine running, and it'll do its thing. It'll go through the test and give you a pass or fail at the end. Or if one of the conditions goes out, it may throw an error, and then you just have to start over again. Next one is coding. So coding is used to teach the ECM parameters by using a code number. Some examples you might have seen out there before is fuel injector coding. Many vehicles, especially direct injection vehicles, have a code, like a 16-digit code or an 8-digit code or whatever, on the top that will tell the computer, here's what my flow rate is. Because once again, manufacturing tolerances vary from piece to piece, so it might flow a little bit different. So you got to plug a number in, and that it goes into a table, and the computer calculates. Another one that's somewhat common is proxy alignment. So that came over when Fiat bought Chrysler. So there are Chrysler, Dodge, Jeep vehicles that need this. Usually the ones with the Fiat stuff in there. But proxy alignment on, say, this Fiat, 2013 Fiat. Body control module stores and compares vehicle configuration data with the instrument cluster as well as with other electronic control units in the vehicle. This process is referred to programming of configuration of systems integrated, proxy, also known as proxy with an X. If a configuration mismatch is detected, the BCM sets a code. Configuration mismatch code will require the performance of a restore BCM proxy configuration routine or a proxy configuration alignment routine using a diagnostic scan tool. So we'll see what we would need to do with that. So we can go in here, and it's actually its own selection. You don't even have to go into the BCM. You just go to proxy alignment and then perform proxy alignment procedure. Procedure is used to display the proxy configuration status of the entire vehicle and copy the proxy configuration data in any required ECUs. Press continue to display the status. So in this case, 2 of them are unknown. 2 of them are all set. So we'll hit continue. It'll copy and paste the information that it needs across all the modules. That way everybody's talking. And it says to complete the process, turn the ignition off and wait for the display countdown to finish. And then it'll be finished. Easy enough. Now we get into where it's a little more foggy. Starts getting a little more foggy when it comes to programming, right? Because you might think of programming as what the next part and that next thing we're going to talk about is. And sometimes OEMs call it that too, and it's not, for our purposes, it's not. So programming is used to change the ECM parameters based on a preset table. Most commonly found in BCMs, body control modules, but can be found in any sort of module, really. Depends on the vehicle. But all doors unlock with a fob. So when I press my key fob once, I want all the doors to unlock, or I just want one door to unlock. Do I want it to answer back when I press the button or not? Right? These are different parameters that can be programmed. So in this case, I'm on my Subaru. I'm going to body integration unit, which is what they call the body control module. I can change a whole bunch of things. Auto lock time's one example. Hit edit. I can go anywhere from 0, 10, 20, 30, 40, 50, or 60 seconds. Let's choose 20. And then we'll hit program. And then it goes to this menu. You could do other selections at the same time if you wanted to do that. Then we hit program again. And it programs it into the vehicle. That's programming. Lesser known, or commonly confused with flashing. Now, flashing or reflashing, depending on what operation we're doing, is used to write software in the ECM. So if we think about, like, I replace a PCM on a Jeep, it's going to ship blank because it's probably used a bunch of different models. So it's blank, but it needs software in order to run. All the chips and stuff are there, but then there's software on there, no code. So the process of flashing the software to the chip is kind of where that comes from. So this comes from way back. 80s, maybe even or 70s could even be. I don't remember exactly how far back it would have been, but it's called flash ROM. The chips are called flash ROM. So you would flash the software onto the chip. And if you needed to redo the software, like do a software update, which they would call a software calibration change in the OE, you need to do like a software update, you would re-flash the chip. So you'd put new software on that chip that already had existing software on that. This makes sense. So that is the process. Now, what do I need to do this? Well, I'm not doing it with a Android tablet, that's for sure. It has to be a Windows PC because no manufacturer out there says you cannot. You have to use Windows. They specify Windows. They all do. So I need a Windows PC. Can't do it on a Mac either. I need a pass-through device of some sort. There's many different ones out there. Pretty much one company makes most of them, and they're all pretty much the same price. So ours is called the Pass-Through Pro 4. Other manufacturers have them out there too, and like I said, pretty much Drew Technologies makes them for everybody. But you do need the interface between the computer and the car. You also need a good internet connection, and you would also need a good battery maintainer, not a battery charger, not a trickle charger. In this case, this is the EEBC 500, I think B model would be the newest one. I heard it might be discontinued for something else, but they're still out there. And what this does is it gives you a perfectly steady, clean voltage to the vehicle, like 14.2 volts. I think you can actually select it up and down too. I haven't played around with it too much, but I have used it a few times for that purpose. But it just gives you a nice, clean signal, clean power that you won't get a voltage spike. You get a voltage spike in the middle of flashing, it may brick a module. You may be able to recover it, you might not. Depends on the car, depends on how badly it got messed up, I guess. And a minimum of 90 amps to do BMWs anyways. Some manufacturers have a lower lower necessity, but in this case, it's 90 amps. And we also have a tool called the EEBC Flash, which is specific for that. Doesn't do all the other battery charging stuff. It just does, for the flash reprogramming. What else do I need? I need software from the manufacturer, right? This table is a little out of date, but it's pretty close. I do know that Infiniti and Nissan have changed over to Consult, but for example, Hyundai or Kia, it's $75 a flash. That's it. You don't have to pay for the software. $75 a flash, right? Or $75 a download. Chrysler does $50 for 3 days, $200 a month, $1,600 a year. Gives you dealer level diagnostics, right? Same with BMW, $2,700 a year. Volvo's out of their mind at $6,500 a year. That's crazy. They are by far the most expensive one on here by a large margin. But they're cheaper for the day rate, so it's kind of weird how they're maths. But yeah, you would need a subscription to whatever manufacturer that you wanted to do a flash on. Then you more than likely also have to download the flash file to go for the particular car you're working on. So all of that, plus I need to make sure my computer fits their requirements. So this is the minimum spec on Ford, and this is the recommended spec. So instead of 4 gigs of RAM, I need 8 gigs of RAM, solid state drive. Also, interesting enough, Windows 7 and 8.1 updating to Windows 10 is not supported. So there must be something that gets lost or doesn't exist that still allows the operating system to work, but it needs it to run the software, right? So all of these different stipulations and parameters. Notice how it also doesn't say Windows 11. And then this was interesting too. So Mazda and Ford don't play nice if they're installed on the same hard drive. So if you install both applications on the same place, they will corrupt each other and neither will work. So you need to either partition a hard drive or do separate hard drives or separate machines. I know, some people that at least used to flash. I don't know if they still do, but they used to have 3 different laptops. They had a domestic and Asian and a European laptop just because of the different software requirements. I believe it has gotten better because it used to be like, oh, you need this version of Adobe Air for this manufacturer, and you need this version of Java for this manufacturer. Oh, and this version of Java for a different manufacturer, and they would only be for that version too. So I think they've gotten better as far as those aspects, but it's complicated. There's a lot of stuff to research. There's a lot of stuff to read. You don't want to brick a module by accident. So we do offer help in this realm. It's called a pass-through assistant. It's been out for a few years. So it will allow you to remotely flash vehicles. So you can set up an appointment. They'll call you. You plug into the vehicle, and then they'll take care of the rest on their end, right? So these are the manufacturers that are covered under that. It's got a Windows 10 tablet. It's got a pass-through underneath. It's got the cable to plug into the car, cable to plug into the wall. Also has a battery maintainer in there as well. You just use jumper cables off the lugs right there. And that maintains the battery. That's 90 amps as well. Also added recently in the last couple of years is this repair guidance to it as well. So one box, they all got updated once this came out. And repair guidance is nice because that is the phone a friend. So say you don't have an A-Tech in the shop, or your A-Tech has just got one that's really kicking their butt, and there's like, I'm at my wit's end. I don't know what to do. So you can call them, and you can the appointment gets made through the box, right? And you can call them, and they will give you a prescription plan or a plan to go and fix this whatever for $50 for 2 weeks on any VIN. So they will stick with you until that car is fixed, or 2 weeks is up, and then you just pay again and you continue. So it's $50 for 2 weeks to have an A-Tech with you. That's a pretty smoking deal, if you ask me. But they do have OE trained, brand specific master technicians on the other end of the phone. And you'll say, okay, well, I did this, and this, and these are the symptoms that I have. And they'll say, okay, well, examples that I've heard talking to these people. It's like, oh, yeah, they had this common problem that I'd seen 1,000 times. So I just said, oh, yeah, go over to the floor mat, pull it back, and there should be a connector under there. Look for water intrusion. Sure enough, there it was. So if you work on the same vehicles over and over and over again, I would suspect after a while you learn what the common problems are, or the common failure points where, oh, yeah, the OEM doesn't think it's a problem, but I've sure seen 200 of these in my lifetime or whatever. So that's the kind of people on the other end of the phone, right? The super techs, factory trained, master techs who know what's going on out there, right? What they've seen in the field. So as far as coverage, the flashing is a little less than the repair guidance, just because with the flashing, some OEMs don't like remote programming, flashing. See, the OEMs call it programming. Remote flashing, they don't like that, or maybe just the agreement isn't there in place. But over here, these are just, hey, I worked at Porsche for 20 years, and now they have a guy who worked at Porsche for 20 years. So this is all over the phone guidance. That this is the remote flashing support. So a good option for you if you need to do any flashing and you don't want to mess around with all the other stuff that comes along with it, because there's a lot of stuff to pain in the butt. Even people who do it for a living, the mobile people that go around, they're still like, yeah, it's still a pain in the butt. Even if they know how to do it, they've done it 100 times. It's still not necessarily the easiest thing to keep up with everything, right? All right, let's go live on the tool. Look at a couple examples. First one I want to look at is on that Cadillac seat. Go seat, motor. And if we look at the wiring diagrams, scroll down a little bit. There's a bladder control module. That's for the lumbar adjustment, right? Let's see, driver seat adjuster switch, and then there's the memory module, right? So this is what we were talking about before. It sends a signal over LIN, so this goes out to the computer data line, and then it goes back over here to the C memory control module, and then it says, all right, do what you need to do, right? Moves the motor, or in this case, there's a lumbar. What's this one? Driver front side door window control switch, right? So that has a bunch of switches with a logic board, and it has a LIN bus that sends stuff out. Operates the mirrors and the mirror glass and all that good stuff. So all sorts of different things run over the LIN. Now, how do I know it's on LIN? Other than it was labeled on those diagrams, but if you have Shopkeeper Mitchell, you go into the wiring diagrams, there's a computer data lines, which will have all the data lines listed. Now, in this case, this is the gateway module, so it's got Ethernet and CAN bus and all sorts of stuff. No LIN, though, in that case. But if I go to the next page, there we go. This is the driver seat adjuster memory module again. And you can see it has multiple LIN buses on it. So that's LIN bus 1, LIN bus 2. It's got these two things. Driver's front seat adjuster switch. So that is the seat adjuster switch. Sends the signal down here into the module. Then the module sends out its stuff to wherever else it might need to go, right? So these are just the data lines. Obviously, doesn't consist of all of the connector or the pins in the connectors, right? So that's one quick way to know if it is. Oh, I didn't want to get out of the vehicle. Activate again. And if we go on the scanner, there's multiple things we might need to reset or relearn. So if I go into the resets and relearns menu, service resets and relearns, we can do I need to reset the oil, calibrate the front camera for ADAS, transfer case adaptives for all-wheel drive, bleed the brakes, that sort of thing, all in there. If I go into the engine and just go into the functional tests themselves under special functions, there's a separate learn and reset section. This is not necessarily unique to this vehicle, but you wouldn't find that necessarily on every vehicle. That's up to the OEM on that one. Let's see, air cleaner monitor set. Let's see, ambient air temperature calculation reset, right? So if I replace ambient air temperature sensor, I can reset it here. Brake pedal position sensor learn. There, we talked about that before, right? So you have to learn it in the engine and inside the body control module. Engine coolant control valve learn. Fuel trim reset. So these are relearns. These are resets. All right. So all these different things you might need to do on that particular vehicle. It's a Cadillac. Next, we'll go to a Ford Bronco Sport. This one has a unique test in there just for the LIN bus, and it's in the body control module. So right there. And we'll go to the BCM, functional tests, special functions, And then you can see we have LIN new module initialization right there, right? So the procedure will configure all BCM LIN nodes such as the rear view camera, intrusion sensor, rain sensor module, and battery monitoring system. After you select OK, some nodes might go into config mode. Hit continue. Turn the switch on. Continue. It's going to count down or count up for about 15 seconds. And then probably another 8 seconds after that. And then it'll be done. So it's just sending the signals, making sure everything gets reset, relearned. And now, done. Procedure successful. Right? So not every vehicle you need to do that. In this vehicle you do. This one also has a battery monitoring system reset to reset the battery monitoring system. TPMS, which would be a relearn, PMI. And then lastly, I want to go in this BMW because there'll be a unique one in there. So here, pull up my service resets. There's 60 of them on this vehicle. And one good example is like replace battery, right? Oftentimes European vehicles, you're going to need to recode the battery to the vehicle. So in this case, we get a little top repairs. We get some bulletins that related to battery. And then if I hit functional resets, it's going to go to battery replacement. So I can come in here, display distance reading at last battery exchange and the one before last. Register the battery exchange or end the service function. So if I hit register that, change the battery. Correct charging operation, the replacement battery must be the same capacity as type as the original. See display history for current battery and type. And then it tells you how to recognize some of the batteries. It's going to be programmed in the next step. Can't be canceled after starting. Goes in and resets it. Easy enough. Another place where this could be helpful with the service resets is we had somebody call into our customer care one day. We were listening into the call, and they said, "Oh well, why doesn't your tool do battery registration on this Volkswagen? I've done it a bunch of other times on Volkswagens. Why doesn't it do it on this one? Doesn't even have it listed." Sure enough, it wasn't where they thought it was, which they thought it was in the engine. That's fairly common for it to be in the engine module, but on this particular vehicle, it was in the gateway module. So they would have had to go into the gateway module to do it. If you use service resets and relearns, it doesn't matter what module it's in. You just hit replace battery, you pull up the functional reset, wherever it's hiding, it gets pulled up out of that module. So that's a pretty handy tool. Depending on how complex the vehicle is, some of it's pretty straightforward, but some of it's not. So a lot of like different engine resets down here. Like replace turn signal. I might need to do a relearn on a turn signal or something because the resistance changes or something like that. So could be quite helpful to you if you just pop in there and say, hey, what have I done? What job did I do? Do I need to bleed the brakes? I can go in there and do the bleed the brakes, right? Replace or calibrate the G sensor. Whatever it might happen to be, I can go in there and see if it's listed. And if it is listed, then I'll have the test available. Instead of having to search in which module it's in, out of the 50 modules on the vehicle, just pulls that learn on you. So that is both LIN Bus and module initialization. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week, and we'll see you on any of our other videos. Have a good week, have a good night, and take care.